Good day. So let's have this example for the triangle method for vectors. So for this problem, compute the value of the angle alpha so that the resultant of the two forces will be vertical. Determine the magnitude of the resultant. So we have two forces, 650 newtons and 950 newtons. The angle between these two forces is 45 degrees, and the angle from the x-axis to the 950 newtons is unknown angle alpha. So let us use the triangle method. So using these two forces, let us just draw the equivalent triangle. So for the 950 newtons, with respect to the horizontal axis, the angle is equal to the unknown angle alpha. Then for vector analysis, we are just to connect the head to tail. So from the for the head of the 950 newtons, we connect the tail of the other vector. This is the 650 newtons. So again, this is 950 newtons. With respect to horizontal, this is the alpha. Then we are to connect. We are to connect the tail of the 650 newtons. And then according to this problem, so we are looking for the value of the angle alpha so that the resultant will be vertical. So let us just draw a vertical line that will close our triangle. So again, this will be our resultant, and it is assumed to be vertical. So to compute for the value of alpha, I will be needing another angle. So let's say this is the angle beta. So how do we compute for the angle beta? So basically, we have, based on our figure, if alpha is with respect to the horizontal and our resultant is vertical, basically we have alpha plus the beta should be equal to 90 degrees. So they are perpendicular. So based on the given, we have 45 degrees. So if we are to extend this 950 newtons, again, the angle between the 650 newtons and the 950 newtons is 45 degrees. So if this is supposedly a straight line, again, so if I just to extend the 950 newtons, the angle between is 45 degrees. So do we know this angle? Okay, let's say this angle is theta. So for a straight line, the angle is equal to 180 degrees. So based on our figure again, how do we compute for the value of theta? So basically, we have the value of theta should be equal to 180 degrees minus the 45 degrees. So basically, the value of theta is now equal to 135 degrees. So this angle, the value of angle theta is equal to 135 degrees. So how do we now compute for the resultant? So take note for this problem, the resultant is also required. So we may compute first for the resultant using trigonometry. The first one will be, I think we can use the cosine law. Okay, so for the cosine law, so let's have the sides of our triangle. The resultant 950 newtons and 650 newtons. Okay, so again, so this is, okay, we have the resultant. Okay, the resultant squared is equal to, okay, so we have the sides, 950 newtons squared plus 650 newtons squared, okay, minus twice of 950 newtons, okay, multiplied by 650 newtons, and the included angle, that is the cosine of 135 degrees. So let's have the resultant is now equal to, okay, so let's have it as 950 squared plus 650 squared, and minus, this is twice of 950 by 650, then cosine of the included angle, that is equal to 135 degrees. Then we take the square root. So the magnitude of the resultant is equal to 1,482.659. So 1,482.659 newtons. So this will be one of our answer, or one of the required of the problem. So that is the resultant. Then the first unknown is the angle alpha. How do we now compute for the value of the angle alpha? So first is we may compute for the value of the angle beta. So again, we have now the value of the resultant as 1,482.659. So based on our triangle again, how do we compute for the value of alpha? So this time, I think we can now apply the sine law. Since we have now 3 known sides and one known angle. So by sine law, I will be using the value of 650 newtons, the opposite side of the unknown angle, beta. Okay, so this is, okay, we have 650 newtons. Okay, 650 newtons, so this is to be divided by the sine of the unknown angle beta is equal to, I will be using the resultant, that is 1,482.659. Then this is divided by the sine of its opposite angle, that is the 135 degrees. So what is the value of beta is now equal to, so this is 1,482.659 divided by the sine of 135 degrees, then to be divided by 650. So it should be, we're taking the reciprocal, then shift sine of that value. So we have that as 18.059 degrees. So we'll be just doing a double check. So we have that as 1,482.659 divided by the sine of 135. And then 650 newtons divided by that value, then shift sine of that value. So 18.059 degrees. So that is the value of beta. Again, they are perpendicular. Okay, the resultant is, according to the problem, is vertical, and this alpha is from the x-axis. So alpha plus beta is basically equal to 90 newtons. So, 90 degrees, sorry. So if you are computing now for the value of alpha, that is basically the 90 degrees minus the value of beta. So we have alpha is now equal to, this is 90 less 18.059 degrees. So alpha is equal to, so we have this as 90 minus that value is 71.941 degrees. So this is 71.941 degrees. So these are our answers for this example. So again, this is a vector problem using the triangle method. Okay, so let's have another example. So this is for the vector problem using the component method. So we are required, for this example, we are required to determine the magnitude and direction of the equilibrant. So these are our vectors, so 60 meters, the 50 meters, 70 meters, and their corresponding direction. So we may convert this given slope in terms of an angle in degrees. So let's say if this is alpha, okay, so we can use tangent. So this is the tangent of alpha is equal to, so the opposite side is 4, adjacent side is 3. So the value of the angle alpha is equal to so we have that as 53.13 degrees. Alright, now so let's have the components of the resultant. So we may first write arrows regarding the direction of the components of each vector. So this for this 60 meters, so one towards the north, the other is towards the east. Okay, when it comes to this 50 meters, okay, towards the north and towards the west. And for the 50 newtons, so towards the south. And the other will be towards the west when it comes to the when it comes to its components. So again, for our sign convention, when it comes to these arrows, so we are using to the right. For to the right vectors, that will be positive, and to the left vectors, that will be negative. So computing for the let's say the horizontal component, or that is from east to west or west to east, let's say we're just using Rx. That will be the summation of the vectors along x. So this will be the x component of our resultant. So for the 60 meters, so we have that as 60, then cosine up 60 degrees. That will be positive since that is towards the east. Then plus, or maybe that or it should be minus. Minus the component of the 50 meters that is towards the left. So we have 50 cosine of 40 degrees. Then minus also for the 70 meters, it is also towards the left. So minus 70, its component is west, is the sine of 50 3.13 degrees, since that is the opposite side of this slope of this angle. So we'll be having the value of Rx is equal to, so again, the horizontal component of the 70 is the opposite of this angle alpha. So we are using sine. Okay, so we have this is 60. Okay, so this is 60 cosine of 60 degrees, then plus 50 minus supposedly. Minus the 50 cosine of 40 degrees, then minus 70 sine of 53.13 degrees. And this is equal to, we have that as a negative, this is negative 64.302 meters. So negative 64.302 meters. So the negative sign indicates its direction. It is towards the west. Okay, then for the vertical component, or that is the north-south or south-north direction, this is for the, let's say just Ry. This is the summation of the vectors along y. So again, we'll be using our east to west as our x-axis, and our north to south or south to north as our y-axis. As we have this as, okay, so what are the components? So for the component of the 60 that is towards the north, then it should be positive. So 60 sine up as 60 degrees. Then plus, also the component of the 50 meters is towards the north. This 50 sine of the 40 degrees. Then minus, the component of the 70 is downward or towards the south. Minus 70, then this should be a cosine of 53.13 degrees. So if this is the angle alpha, 53.13, the vertical component is just adjacent. So we are using a cosine. So computing for that value, we have that as 60 sine of 60 degrees, then plus 50 sine of 40 degrees, then minus 70 cosine of 53.13 degrees. So we have this as, okay, so we'll be just using 3 decimal places. So Ry is equal to 42.101 meters. And if it is positive, so its direction is towards the north. So we have now the horizontal and the vertical component of our vector. So for the horizontal component, that is Rx, okay, we have that as, okay, towards the west, so it is negative 64.302 meters. Then for the vertical component, that is towards the north, so this is our Ry is equal to 42.101 meters. Then this will be our resultant. So the value of the resultant can be computed as the square root of, we have Rx squared plus, we have the R sub y squared. So we have the resultants now equal to, this is the square root of, we have negative 64.302 squared plus the 42.101 squared. Okay, so this is the square root of the negative 64.302 squared plus 42.101 squared. So we can have it as 76.859. So 76.859 meters. Okay, then if we are to compute for its direction with respect to the horizontal, let's say this is the value of the angle theta. So how do we compute for the value of the angle theta? So we may use a tangent. So it says the tangent of theta is equal to opposite. We have Ry divided by Rx. But okay, if you are using for if you are to compute for the value of angle theta, we should use the absolute value since we have a negative component here. But as long as we are aware of the direction, so we should use absolute values. So this is equal to the tangent of theta is equal to the absolute value of 42.101 divided by the negative 64.302 meters. Or basically, we are just using positive values. So the value of theta is now equal to, so this is the shift tangent of 42.101 meters divided by 64.302. So we can have it as 33.214 degrees. So if we are now to write or draw our resultant, So again, so this will be the direction. Okay, so the direction of our resultant R, and based on the computed angle, so with respect to the direction or from the west direction, okay, the value is equal to 33.214 degrees. But if we are to go back on our problem, so determine the magnitude and the direction of the equilibrant. So the equilibrant is acting directly opposite of the resultant. So this will be the direction of the resultant. And it is numerically equal to our resultant. So we have the value of the equilibrant is also equal to 76.859 meters. So this will be the value of our equilibrant. When it comes to its direction, if this is 33.214 degrees, this angle is also equal to 33.214 degrees. So this is the east direction, this is the south direction. So our answer, so that will be 76.859 meters. That will be the magnitude of the equilibrant, and its direction is 33. We have 33.214 degrees. It is south of east. So this will be our answer for the for this problem. So 76.859 meters, direction 33.214 degrees, south of east. So again, this is our example for the component method for vectors. So another way to solve this problem by component method is using the mode complex of our calculator. So let's say this will be our solution number 2. So for the mode complex of our calculator, we'll be having the summation. We'll be needing the summation of the vectors or the distances. The summation of the vectors, then their corresponding angle from the east direction. So considering counterclockwise angles will be positive and clockwise angles will be negative. So just their angles from the east direction. So when it comes to the given, so for example, we have this 60 meters. Its corresponding angle from the east direction is the same as the 60 degrees. So for this 50 meters, its corresponding angle from the east direction is if this is 40 degrees, 180 minus 40 is 140 degrees. Okay, then for the 70 meters, its corresponding angle from the east direction is 50. If this is 53.13 degrees plus 90, that will give us 153.13 degrees. But again, if it is clockwise, this angle should be negative. So we'll be using negative 153.13 degrees. Now we proceed to our solution for the mode complex. That will be, we have that as 60. Its corresponding angle from the east direction is also 60 degrees. Plus the 50, this is 50. Its angle from the east direction is 140 degrees. Then plus we have the 70. Its angle from the east direction, it is clockwise. So we'll be using negative 153.13 degrees. So input on our calculator. So we'll be using mode number 2, mode complex. So we have, this is 60, shift of the negative sign to have the angle sign of 60 degrees. Then plus we have 50, shift a negative sign of 140 degrees. Oh. We are just to repeat. So this is 60, shift negative sign. This is 60 degrees plus 50, shift a negative sign 140 degrees. Then plus the 70, shift negative sign. This is a negative 153. Or is it 153? Let us just counter check. 53.13 degrees plus 90. This should be 143 only. So correction on that. We have only 143.13 degrees. So again, correction. It should be only 143.13 degrees. Again, we go back to our calculator. Okay, so again, this is 60, shift negative sign, 60 degrees plus 100 plus 50, shift a negative sign, 140 degrees, then plus 70, shift a negative sign of negative 143.13 degrees. So the resulting form of the complex number will be in the form of a plus bi. Since we are in a complex number, all you have to do is shift number. What number is complex? Shift number 2. So using again, this is shift number 2. Shift number 2. Then we are to use number 3. So we are to look for this value, the r angle theta, which is number 3. So press number 3, then press equals. So this will give us the value. We have 76.859. And then its corresponding angle is 146.786. 146.786 degrees. So we are now in that form using mode complex. This is one of the requirement already. This is our resultant. So did we arrive with the same resultant before or earlier? So yes. So using the other method, so we arrive with the same value of 76.859 meters. But what about the angle? The angle is 146.786 degrees. Again, this angle is an angle from the east direction. So this is a theta sub E. So if we are to plot this angle, okay, so basically what is 146.786? So that is positive, which means it is counterclockwise. So from the east direction, we have that angle. This angle is 146.786 degrees. Again, our markers, this is 90 degrees, or our references, this is 180 degrees. So it is less than 180 but greater than 90. So this is 146.786 degrees. So this will be the direction of our resultant, which is the 76.859. How do we compute for this angle theta? Let's say we have that theta. How we compute for that theta? That is equal to, so we proceed to mode 1, 180 degrees minus 146.786. So we have that as 33.7 33.214 degrees. So again, this is 33.214 degrees. So same value as computed from our previous method, the 33.214 degrees. But again, that is the direction of the resultant. And the required for this problem is the direction of the equilibriant, which is acting directly opposite of the resultant, with the same magnitude of 76.859 meters. And this angle is also equal to the 33.214 degrees. So the direction, this is south direction, that is 33.214 degrees south of east. So again, this will be our answer for this example using the mode complex of our calculator. So by component method and by mode complex of calculator.